I will explain in this video is electric field due to infinite sheet of charge. Electric field due to infinite sheet of charge. Consider coordinate system, cylindrical coordinate system, X, Y, Z. Consider an infinite sheet of charge in the XY plane with uniform charge densities rho s. Infinite sheet of charge. This one is infinite sheet of charge. Consider an infinite sheet of charge in the XY plane. This is the XY plane with uniform charge density rho s. Uniform charge density is rho s. This one is XY plane. The sheet charge, the infinite sheet of charge located on XY plane. This one is 0. The charge associated with a small element area ds. Consider ds here, small element here. This one is ds. The point here, find out the electric field intensity at point P due to a small element ds on this charge sheet like that. This one is rho. This one is d phi. This one is d phi. Not phi. This one is pi. R vector. This one is R. This one is Z axis like that. Another sheet of charge associated with here is this one is the infinite sheet of charge. Here we have to assume two elements. This is element 1 and element 2. This one is origin. Again connected this one. Connected like this. Electric field, find out the electric field intensity here, 0, 0, Z. Consider, first point here, consider an infinite sheet of charge in the XY plane with the uniform charge density. rho s, shown in figure. Charge density is rho s. This is placed on the xy plane. This is the ds element. The charge associated with that ds element is dq. Therefore, second point here is the charge associated with with an element area ds is. Therefore, dq is equal to rho s into ds. Rho s into ds. Third point is the electric field intensity at point P, that means 0, 0, z, by the elemental surface 1. This is the small elemental surface 1 shown in figure is electric field at a point P. Electric field at point P, that means 0, 0, z, by the elemental surface 1 shown in figure is dE is equal to dq by 4 pi epsilon r square a r here. The charge dq is the charge associated with an element area ds is dq into dq is equal to rho s into d. Generally, rho s is equal to dq by ds. Dq by ds. Fourth one important point is this one is y, z, x. The component z along az bar is z into az dash, z into az bar. Here consider small element. Here the small element in that sheet. Consider point here. This one is making phi. This one is rho. This one is point P. R. R vector. This one is R vector. Here generally here direction is like that. Arrow direction is like that. But in this case, the direction of that arrow is the radial component of rho along minus arrow minus AR dash. This one is minus arrow dash, minus arrow dash, not AR, arrow dash. This is the arrow, the point here. The distance vector, this is the distance vector R, has two components. The distance vector R dash has two components. First one is the radial component. First one is the radial component. Rho along minus arrow, that is minus rho into arrow dash. Second one is the component Z. ln az dash is z into az dash. Therefore, finally, the distance vector r is equal to minus rho into a rho bar z into az bar. In the electric field intensity, ar bar and r square is there. First of all, find out a r bar. A r bar is equal to r bar by mod r. R bar is minus rho a rho bar plus z az bar by square root of rho square plus z square. Therefore, electric field intensity formula is, we know that dq by 4 pi epsilon 0 r square ar bar. dq is rho s into ds. dq is rho s into ds. ar is ar bar by 4 pi epsilon r square. 4 pi epsilon r square. Here ds is ds normal to z direction is here. This one is ds. Charge associated with ds is dq. ds important point here is ds normal to z direction. This is the sheet that is normal. This is the sheet. On that sheet, we consider small element. This one is small element on that sheet, like that. Normal is z. ds normal to z direction is rho d rho d phi. Rho d rho d phi. Z is not there. ds normal to z direction is rho d rho d phi. Substitute here in place of ds. That is rho s. ds is equal to rho d rho d phi ar bar by 4 pi epsilon 0 into r square. This is d. This is d. d is equal to rho s rho d rho d phi, but ar is ar here, ar bar here, ar bar is equal to here, ar bar is equal to minus rho a rho dash plus z a z bar minus rho a rho bar plus z into by square root of rho square plus z square, but r square is equal to rho square plus z square. That is equal to rho s rho d rho d phi minus rho a rho plus z into a z bar by Here 4 pi epsilon 0 is also there. 4 pi epsilon 0 rho square plus z square whole power 3 by 2. Here this one is the sheet. An infinite sheet of charge in the xy plane. Here, consider this is the small element. Here also small element. Due to symmetry of the charge distribution for every element 1, this is the element 1, this is the element 2. Due to symmetry of the charge distribution for every element 1, there is a corresponding element 2 here. For every element, corresponding opposite element is 2. Corresponding element is 2, whose contribution along arrow cancels that of element 1. Here some arrow minus arrow direction is also here. Some arrow direction is also arrow direction is there. These two are cancelled to each other. Therefore, rho arrow component is offset. Therefore, the electric field intensity is along that direction only. Due to the symmetry of the charge distribution, for every element there is a corresponding element 2, whose contribution along arrow cancel that of element 1. Whose contribution along arrow cancels that of element 1. Opposite to each other, these two are cancelled to each other. Finally, minus rho arrow value is 0. Therefore, dEz only. dEz is equal to rho s rho d phi d rho z az bar z az by 4 pi epsilon 0 rho square plus z square 3 by 2. Here phi is equal to, the value of phi is equal to 0 to 2 pi. Rho is equal to 0 to infinity. Rho is equal to 0 to infinity. By using these two limits, find out the z along z direction. Ez is equal to phi is equal to 0 to 2 pi. Rho is equal to 0 to infinity. Rho s rho d phi d rho z az bar by 4 pi epsilon 0 rho square plus z square whole power 3 by 2. This pi value is entire. We consider pi is entire 360 degrees. And rho value, this is the rho value 0 to infinity. Consider these two. That is equal to rho s by 4 pi epsilon 0 integral phi is equal 0 to 2 pi d phi rho is equal to 0 to infinity, that is equal to rho d rho z az bar by rho square plus z square 3 by 2. Let rho square plus z square is equal to rho square plus z square is equal to some u square. Here rho is equal to 0 to infinity. Differentiate above equation with respect to rho. 2 rho d rho is equal to 2u du. 2 to cancel. Therefore, rho d rho is replaced with u du. Rho square plus r square. Rho square plus z square 3 by 2. Rho square plus z square is u square. U square and square is cancelled. U cube. Simplify this one. Limits. Rho is equal to 0. Rho is equal to 0. U is equal to z. Rho is equal to 0. Rho is equal to infinity. U is equal to infinity. Therefore, that is equal to rho s by 4 pi epsilon 0. Pi is equal to 0 to 2 pi d phi. U is equal to z. U is equal to z to u is equal to infinity. Here rho d rho is equal to u du z z bar. Rho square plus z square is equal to u square into 3 by 2. That is u cube and u that finally u square value is there. Therefore, rho s by 4 pi epsilon 0 phi is equal to 0 to 2 pi d phi u is equal to z to infinity du by u square z az bar. Rho s by 4 pi epsilon 0 phi is equal to 0 to 2 pi d phi minus 1 by u. 1 by u square is minus 1 by u z to infinity z az bar. That is equal to rho s 4 pi epsilon 0 2 pi 0 minus 1 by infinity minus of minus 1 by z az bar. That is equal to rho s by 4 pi epsilon 0 2 pi 1 by infinity 0 minus plus 1 by z z is cancelled, pi is cancelled. That is equal to rho s by 2 times here 2 pi is not there here, pi is not there. To epsilon 0 rho s by 2 epsilon 0 volts per meter. That is z. Now Az is direction normal to differential surface area ds consider. This is the ds. That is A normal to differential surface area ds. Therefore, finally E is equal to rho s by 2 epsilon 0 an volts per meter. This is the electric field intensity due to infinite sheet of charge.